Hello everyone, welcome once again. Now this is the final part on PDF for continuous variables, and then the question says that the amount of time in hours that a machine functions before breakdown is a continuous random variable with PDF, and then we are given the function f of t being equal to the piecewise function 1 over 20 exponent minus t over 20 and t greater or equal to 0, and then 0 also t greater than t less than 0. And then the first question says that we should find the amount of time in hours that a machine will function between 98 and then 48 hours before the breakdown. So we are given some kind of boundaries, right? A boundary between 98 to 48 hours, and then basically this is a PDF, and then we can then go straight to find the integral of the function that we are given the boundary conditions 98 and also 48 hours. So let's quickly do that. So in here we have the integral of f of x here, let's say ab, right, dx in this case. But then in this case we are given the upper limit to be 1, so the upper limit was given as 145, and then the lower limit to be 98, and then we have the function 1 over 20 e exponent minus t over 120 here. So we have dt in this case. So let's go ahead and then integrate this. So integrating this, what we can do is to just bring 1 over 20 out. This is a constant. 1 over 145, and then 98 here. Then we are left with e exponent that, and then we are integrating that with respect to t. So from here, integrating that, we have 1 over 120 out, and then we have so integrating the whole of that, we have, so integrating this, always what we do is to just write this whole thing and then try to differentiate what is here. So just differentiating what is here with respect to t. So what we are doing to differentiate this only, minus t over 120 is just negative 1 over 120. So we'll write the whole thing 120, and then we divide by the differential of that. So that is negative 1 over 120, and then we have it from 145 and then 98. So from here we have 1 over 120 here, and then writing this, because we have the whole of that multiplied by just 120 over negative 1. So it's just we have, let's bring the negative outside here, then multiplied by 120, because when we simplify that, the 120 goes to the top, and then we have e minus t, e exponent minus t over 120 here, and then we have 145 and then 98 here. So from here 120 gets rid of 120, and then we have just negative, and then let's compute that. So we have 145 and then 98 here. So substituting the boundaries into it, we have just negative 145 over 120 here, right? And then the second part is minus e to the power minus 98 here divided by 120. So we have this, and then when we compute this, we should get the value to be equal to 0.14308, and that will be for the first part. Now the second part of the question says that what is the probability that it will function less than 160 hours? So less than 160 hours, we are looking at the probability that t is less than 160 hours, right? 160 hours. So let's look at that. So the probability that t is less than 160 hours, and then remember then again that the boundary conditions that we are given from the general function is that it says that t is less than 0, and then t, t greater or equal to 0 from here. So which means that in this case, because we are given that we should find the probability that t is less than 160, 160 becomes the upper limit, and then whatever is less than t, which is the general condition we are given over here, which is just 0, becomes the lower limit. So in this case, our upper limit is 160, our lower limit becomes 0, and then we have so we can just bring the 120 outside, and then we can just have this inside here, and then the t here. Right, now from here we go ahead and then integrate. So integrating that, we have 120 outside here, and then still integrating that, we have minus t over 120 here, remember, divided by the differential of the exponent, which is -1 over 120, right? And then the conditions were given 160 and then 0 here. So from here we have the probability that t is less than 160 here being equal to so in this case we have 120 here, then multiplied by -120, because this 120 moves to the top, and then they cancel out. So what you are left with is e to the power minus t over 120 here, and then you have 160 and then 0 here. So we are left with negative outside, and then e minus t over 120, that is from 160 and then 0. And then from here we have this to be e to the power -160 divided by 120, and then minus e to the power here -0 over 120 in this case. And then computing all of that, we should get 0.736403, and that will be the answer for t less than 160. So thank you very much for joining in this section, and this is the last lecture on the continuous variable. But then the next lecture will be on, or the next example will be on the central limit. We're going to talk about central limits, normal distribution, sampling distribution, the z distribution, and also the t distribution, and then we'll solve some examples from there. So thank you very much. Please like, subscribe, and also hit the notification bell to be notified anytime we post a new video. Thank you very much, and I'll see you guys in the next section.